Welcome Calculus 2 students to the next lecture on parametric equations. We're going to begin with the two equations on the board, x equals 3 minus 2t, y equals 7 plus 5t. We're going to find out that this is actually the parametrization of a line, although that may not be obvious to us at the moment. The method we're going to use is something called elimination of the parameter. This is a skill that you're going to need on several homework problems, even when they're not about lines per se, but just converting parametric equations into the standard Cartesian equations relating x and y with which we have experience before. So let's see how this goes. We've got x equal 3 minus 2t. I'm just going to solve for t by subtracting 3 and then dividing by -2. And so I have t equals x minus 3 over -2. Likewise, because I know y is 7 plus 5t, I'll subtract 7 and divide by 5. Because I know that t is equal to both this expression and this expression, both x minus 3 over -2 and y minus 7 over 5, I know that those two expressions are equal to each other. And so I have x, let's do the y first, y minus 7 over 5 has to be the same thing as x minus 3 over -2. If I multiply both sides by 5, I can see that I have the equation of a line in point-slope form. And a point on the line is given by 3, 7, and the slope of the line is -5/2. And so in this way I can see that these pair of parametric equations actually describe a line. Let's see if we can generalize what's happening here. Suppose instead I have x equals a plus alpha t and b plus beta t. Let's replicate the elimination of the parameter that we just used in the preceding example. So we have x minus a equals alpha t, and therefore t equals x minus a over alpha. And likewise, y minus b is beta t, and so t is y minus b over beta. This tells us that y minus b over beta is equal to x minus a over alpha, so y minus b is equal to beta over alpha times x minus a, which will be a line through the point AB that has slope beta over alpha. Now, of course, that assumes that alpha is not equal to 0. If alpha is equal to 0, on the other hand, while your y is changing, your x is not, and you would have a vertical line. So we can make a note here. If alpha is equal to 0, the line is vertical and has no slope. So in this way, we can see that every parametric equation pair of this form is going to describe a line. Next time we'll do another example of eliminating the parameter to see other types of parametric equations.